Hello and welcome to part 4 of the Trigonometry Review from Stevens's Matrices, Vectors, and 3D Math, a game programming approach with MATLAB. And the Trigonometry Review portion, this is Appendix A, has 6 parts and then a problem set. So we've done triangle trig, we've done unit circle trig, and we've considered trig as a collection of periodic functions. And now in this particular video, we're going to take those periodic functions, do some translations, transformations, and give them different shapes and periods and things like that. Alright, so part 4, here we go. So first thing I'm going to do is put this into full screen mode. And I need to broaden this out so that we can see the whole page, the width. There we go. Okay, so the first thing we're going to talk about are horizontal and vertical translations. And now this is consistent with any function, not just trig functions. So the way this looks, if you have a function that looks like this, or this is the same thing, only sine. So we have cosine or sine. What this does, if you subtract something from the value of x within the function, that shifts the curve to the right, this by this amount. Shift right. Now you look at that minus and you might think, oh, why doesn't it shift it left? But it's a little counterintuitive. If you have a subtract a positive number, that is a shift to the right. And then if you take the function and you actually add a constant to that function, that is a vertical move, right? Vertical shift. Specifically, if that's positive, it's going to bump the curve up. If it's negative, it's going to bump the curve down. And it doesn't matter whether I'm talking about cosine or sine. Those actions, subtracting a value from the independent variable such as x, moves the curve to the right that many units, and adding something to the entire function moves it up or down depending on the sign. So for example, if I look at the dashed curve here, that's cosine x. So that's this curve right here. If I want to move it to the right, pi over 2, and move it up by 1 unit, what I would do is I would take cosine x minus pi over 2, so that moves it to the right pi over 2 and bumps it up by 1. Right? And this doesn't even have to be sine or cosine. That's any function. You think of f of x minus a is sometimes how you'll see it. That's a shift to the right. Or if you take f of x plus b, that is a vertical shift up, if b is positive. Okay, so that's how those are called translations, where you just take the whole curve, move it left, move it right, move it up, move it down. If you want to talk about amplitude changes, here's what I mean by an amplitude. If you look at the dotted curve, that's cosine x. It has an amplitude of 1. All right, it means it starts at 0, goes up to 1, down to negative 1. So the amplitude is considered 1. You can take the total range, say, and divide it in half if you'd like. If you want to increase that amplitude, make it go up higher and down lower, right? Then what you have to do is you multiply that function, cosine x, or sine x for that matter, by something called a. Whatever is out in front of there is called the amplitude. And if it's just a 1, then you have the standard cosine curve. If you say change it, so that's what we had. The dash curve was our cosine x. If we stick a 2 out in front of that, it makes our solid curve here, which goes up 2 and then down 2. So it increases the amplitude. And you can make it have a smaller amplitude, sort of squishing it down by multiplying it by, say, 1/2. Right, so y equals 1/2 cosine x would actually just squish it down. Alright, so we have translations, pretty easy. Amplitude changes, pretty easy. The one that occasionally trips people up is changes in period or frequency. And here again, it doesn't matter whether we're talking cosine or sine. If we multiply our independent variable x, or sometimes it's t, by a value other than 1, it changes the frequency. In fact, this term this omega, it looks like a W, if you will. It's called the angular frequency, or sometimes just the frequency. And what it does to the period is that it takes the period, which is usually 2 pi, right? Sine and cosine have period 2 pi, and it divides that period 2 pi by W. So the bigger this omega or W is, the smaller the period, right? So for example, if you look at this dashed curve, that's y equals cosine x. It has a period of 2 pi, right? Remember, we're looking at this dashed one. Period 2 pi, cosine x. If I multiply that x by 2, what that does is it cuts my period in half, right? And if you'll notice, that's exactly what happened here. Now my period is just half of that. It went from 2 pi to pi. That's this solid curve. Right? That's cosine 2x. Right? So the bigger you make omega here or in sine here, the faster this thing oscillates up and down. Hence the name, the frequency. Okay, so that is how you take your trig functions, sine and cosine, and you can change them around. You can give them faster frequencies. You can change the period, right? You can move them up, down, left, right. You can stretch them out vertically or squish them down with these transformations and translations here. So the next section will be on creating circles and ellipses with trig functions using parametric definitions. And that is the next video. I will see you then. Bye.